We all want to see space like in the movies, but what our telescopes can really do is as far from that as the sun is from the other stars. This won't be a movie. From here on, only 3i Atlas real footage. Look at this fuzzy little glow. That's the comet as the Hubble Space Telescope first saw it in the summer of 2025. Why so blurry? Because it's tiny, very far away, and its light is weak. It's wrapped in a coma, a cloud of gas and dust around the nucleus. The coma shines, but the nucleus, the solid core of the comet, is hidden inside it. That's why we can't just zoom in and see the core directly. Now the strangest part. A comet has a tail. We're used to seeing that tail stretch away from the sun. Why? Sunlight and the stream of solar particles act like a wind, pushing dust and gas outward. Think of a hairdryer and glitter. Turn it on, and the glitter flies away from the dryer. That's a normal comet tail. But here we see an anti-tail, a bright line that seems to point toward the sun. It's not magic. The sunlit side of the comet heats up, and the ice there turns into gas more strongly. Some particles, the bigger, heavier ones, survive longer and line up in a way that, to us, looks like a beam toward the sun. So it's not the sun pulling the tail inward. It's geometry and particle behavior drawing that odd shape. Then time passes. The comet gets closer to the sun, and the temperature rises. Now the ice starts to vaporize from many parts of the surface, not just one side. The gas outflow grows stronger, and fine dust bursts outward. Those heavy particles that used to anchor the anti-tail lose their advantage. They either sublimate away or get overwhelmed by fresh outgassing. This is the turning point. The anti-tail fades, and a normal tail takes over, clearly stretching away from the sun. Next comes perihelion, the moment when the comet is closest to the sun. It's like stepping right up to a bonfire. This is when it heats the most. Inside, things are boiling. Ice becomes gas. Material bursts outward. Some comets even break apart. They can't handle the heat. 3i Atlas seems to have survived, but it changed. The tail is now the classic kind, long, bright, and unmistakable. It's not the same object we saw earlier. You might notice narrow streaks in some images. Those are jets, thin, focused streams of gas and dust. Imagine tiny geysers. A patch of ice warms up, cracks, and whoosh. Out comes a jet. Several jets can look like a fan. Depending on the angle, a few can even resemble mini anti-tails. You might ask, what can scientists really learn from such fuzzy pictures? A lot. They compare images in different colors of light, subtract background, and check where gas and dust shine the most. It's like hearing an orchestra and picking out the instruments by ear. The view may look plain, but the data tell a full story. What the cloud is made of, where the activity is strongest, how the tail changes, and what happens before and after perihelion. Comet 3i Atlas is a visitor from another star system. We don't get to choose how photogenic it is. We do get to choose how carefully we pay attention to its light. The film will end, the data will remain, and for that, respect to the people who make the impossible possible. The telescopes, the engineers, and the teams who turn dim dots into understanding.